Okay, so we're at the place in the, the problem where you whip your calculator out now and do the computation. So what I want to do is I want to go to my Sage application, and I'm going to reset. I'm going to type in a variable t. I got that covered. I'm going to type in p of t. It's always a problem when you're typing things in that you got to type in the right thing. So it's 15,000 divide by, it looks like 1 plus 24 star e, and then e is going to be raised to a power. And that power, just looking at it, it looks like, I gotta be careful here, it looks like minus, I'm going to say the log, L-O-G. Now log in Sage means natural log. And what am I doing? It's going to be 6 divided by the square root of 11. Let me pull this over so we can see it. Sorry about that. Let me pull it down. Let me pull this up a little bit so you can see what I'm doing. All right. So I'm going to close the log out now. Times t. And I'm going to close the bottom out. I'm sorry, the power out, and then the bottom out. I'm going to hit return, and there's always a possibility to type something in incorrect, right? So I'm going to say it looks like it did okay, right? Now again, certainly when you're doing this at first, you're going to make mistakes. So let me put on what I typed in. I just typed in the function now. That took some time to derive, by the way. We did derive that function, by the way. What I want to do is go back to Sage and type in p of the number 4 now and see what it gives me. And what does it give me? It gives me, whoops, sorry about that. It gives me 32,400 divided by 7. Again, if we went back to the actual key in the problem, which was the choice they gave me, I don't see that anywhere, right? So what I would do is approximate this, all right? So I'm going to put down, underscore again means the output of the prior input, and I'm going to do numerical approximation. And what do you get? 4628.5, all right? Now, someone's going to say that really should be rounded to 4629. What I notice about black pen, red pen, is he approximates numbers as he moves along. I do not approximate numbers until the very last step, which I really think is the appropriate thing to do, not to round until you're at the very, very last step of the problem. All right, but again, he tends to approximate. And the reason that he's writing the stuff on the board, and it's easier to write down an approximate than it is to write down the actual arithmetic in the problem. Let me put out what I mean by that. For example, I believe what he does over here. Let me type this in. Whoops. I would write it down this way. What would he do? He'd write an approximation down for it. And he'd write down, oh, it's about 0.5928. But I want to be honest with you. What happens is you're losing a lot of things that the calculator can do for you that you don't have to worry about, is all those other numbers there. And it does have an effect, and it does accumulate. What I mean by that, if this calculation goes on for some time and you keep rounding down or rounding up, whatever, it's going to have a major impact on the output, all right? Now, here does that have a major output effect on the output? No, not really. What number are we saying? 4628. 0.5. I would have rounded off to 4629. But again, I don't see that answer listed. But I would say, oh, there must have been some kind of round off, and I'd say 4628. Thank you so much.